Okay guys, let's continue with our exercise about high order functions now. So this is the factorial function, we define it later as before, and we will continue now creating a new function. It's for some values from 1 until reach the value of the second parameter of the function, in the case 3 or 4 or 5. And at the Scala, when you are not defined yet your function, you can use the signals here, question marks. When you put 3 question marks, it means I didn't encode it yet, but I will, right? Okay, so let's implement it. The first sentence here is A. If A greater than B, it returns 0. Why? Because the A first parameter here will be sum until reach the B. So if it's greater than B, so stop and return 0. 0 won't change our result here. Our final result will sum with 0, so there's no problem. Else A plus sum A plus 1 B. Okay, and let's test our function. Sum 1, 2, 3. The final result is 6, right? It easily confirm 1 plus 2 plus 3. So 3 plus 2, 5, plus 1, 6. How it works? It's exactly the same thing with we did in a factorial function. Exactly. And Scala try to evaluate this first. It's false, and we'll get high in the second branch. And you try to evaluate the first value of A is 1 plus the result of here will pass 1 plus 1, and after 2 plus 1, and after 3, so it will returns recursive the sum of the numbers. Let's define more two functions for testing our high order function sum A. It's a quad function. It returns A multiplied by A in a quad, and a cube A multiplied by A 3 times. Let's test with 3, the quad of 3, and the cube of 3. Will be evaluated here with 9 and 27. Okay. Our new function sum at the top will receive a function with the first parameter is an int and return an int, and receive the same parameters as the sum the previous defined. How it works: when you pass a function as a parameter here in Scala, it will evaluate and execute it dynamically. Let's see it in practice. If A greater than B, returns 0. The same. It's the same logic from the previous sum. Else, and here starts the magic. We'll call the function here into the first parameter, f of A plus sum A plus 1 B. It won't compile, of course, because it is missing a parameter, right? Our sum A receives as a first parameter a function, so you must pass it again because it's a recursive call. Right, let's test with the factorial function. Factorial receives only one parameter, so it will serve for us for test. Factorial 1 2 3, it will be to 9. It's almost the same thing from the previous, almost the same value of the sum here. Oh no, it's much more. Sorry, it's 9 in the higher order function sum, and it's 6 in the sample version. Let's try here sum a with quad 1 2 3, and the result will be 14. It's much more than before. And sum a cube 1 2 3, 36. What happened here? Right, and we are using the same function with 3 different functions. It's a very powerful resource, and the feature is very interesting because you can reuse the same function, the same core of function with different functions. You only have to guarantee that the function that you're passing receive the same parameter as determined here. For example, def u sum b, for example, a and b and returns an int. It only returns the sum of a and b, so we can't use this function as parameter for the sum a. It won't compile, right? Because the parameters are completely different. Type mismatch expected int, but you're passing 2 ints, it won't works, right? So that's it about high order function. It's a very powerful feature in Scala. Can reuse a function with or different infinite type of another functions using the same core.